Hello, in this part we are going to learn about templates in C++. Templates allow us to write generic code, meaning the same code can work with different data types. Okay, so they help us avoid code duplication and make programs more flexible. So a template is like a blueprint for functions or classes. Instead of working with a specific data type, we use a placeholder type. So the compiler replaces the placeholder with the actual type when the program runs. Okay, so let's start with a function template. Okay, so let us create it right here. So above our main function, what we are going to do is to create our template. So we are going to use the template keyword, template keyword, and this template inside here we are going to provide the type. Okay, so the type here we are going to use the type name. So we are going to use type name. Type name is going to be, let me call it T. Okay, after T, then inside below this one we are going to have our T, and then we are going to use add. We are going to call it add. Then we are going to provide certain parameters. We're going to have T, it's going to be A, and let us have T, it's going to be B, called B. Then from there I'm going to explain everything deeply. Okay, after typing, so we are going to return a plus b, like that, then semicolon. Then from there inside our main function we are going to use console out, and then we are going to output the returned value of add. Okay, and then we are going to provide 3 and 4. Okay, then from there we are going to move the cursor to the next line using the end L. Then from there we are going to also output using cout. We are going to output add, but let us provide 2.5, 2.4, 2.5, anything that we want, and then let us provide 1.5, like that, then semicolon. Okay, so here template right here above, so here template type T with the angle brackets declares the template. Okay, and T represents the data type. Okay, so the same function works for int and double. Okay, so as you can see here. Okay, so the same function has worked for integers and also for integers and also for doubles. Okay, as you can see. Okay, so that's it. So why should we use templates? So without templates we would need separate functions for each data type. Okay, as in this case we shall need one for doubles, one that accept doubles, and one that accept integers. Okay, so we would need separate functions for each data type, and templates allows one function to handle many types. Okay, so let us now take a look at class template example. So templates can also be used with the classes. Okay, so for instance let us not remove this line. Okay, right there, let us just remove this one, because this one is a function template. Okay, so let us remove it and let us create a class below it. Class, let me name it box, and inside our box, so this class, this is a class, not a function. Okay, so and from there let us inside here, let us have some public attributes. Let us have only one attribute. Okay, one attribute, let us call it value. Then from there let us create a constructor, a box constructor, and it's going to take one parameter. Okay, so let me call it v. From there let us try to set our value to be equals to v. Okay, so from there let us try to create our object down here. Let me try to remove these two lines. Okay, so this one returns an int. So from there, this class, we have to end it with a semicolon. Okay, like that. Then from there, inside our main function, we are going to create our box object. Okay, box object, and this object box object is going to take in integer. So as you can see, we can specify int there, and from there this is going to be integer box. Okay, and let us provide 10, like that. And from there let us try to create another one, box, but this one is going to accept a string, like that, and let us call it string box, a string box. Okay, then this one is going to take in hello, like that, okay, in our constructor. Then from there we can output cout, okay, and we want to output int box dot, let us get access to the value, and let us move the cursor to the next line using end L. Then from there let us also output our string box dot value, our value, okay, like that in the string box object. Then from there let me explain what's happening. So box here, the box and the type box, and these types, these ones, this one is now a generic class, okay, is a generic class, and the same class works for different data types, okay. As you can see here, we first used it with integers and integer, and now we are using it with a string, okay. And so C++ can automatically detect the type in many cases, okay, in many cases. So as you can see here, okay, right here, and if we try to hover over, as you can see here, we have a string, okay, and for this one we have an integer, okay, like that. So the compiler figures out the t, okay, when compiling, okay. So let us now take a look at multiple template parameters, okay. So for multiple template parameters, we can change this one. So let me try to, let us try to even if we delete these lines, okay, because I'm going to provide another example, okay, so that you get used, okay. So we are going to create another template. So template, instead let us not repeat this line because we have it here. So this one is going to be type name t, and let us have another one. Let us use type name, this one, let us name it u, okay. So it's better to use upper cases, okay, for these types, okay. Let us use upper cases. You can even say, you can say type name, you can say r, anything that you want. You can say r, you can say h, like that, okay. So but let us stick with t and u, like that. Then from there let us create our method. Our method is going to be display, and display is going to take a and b, okay, of type t, okay, and u, okay, so respectively. So we have this one's going to be b, like that. Then from there let us create a body. So we are going to output, let us output a, and after there we are going to add a space, or let us add a comma, and again we are going to output our b, like that, and then we end with a semicolon. Then from there, inside our main we can create our template, okay, like that. So templates can have more than one type, and each type can be different, okay. So let us take a look at the common mistakes, okay, that most beginners do, okay. So common template mistakes include forgetting to use the template and the type, the template and then the type, okay, the type keywords, okay, the type name keywords, okay. So use, and the next one is using operations not supported by all types, okay. So and lastly, writing overlay complex templates, okay. So let us take a look at when to use templates, okay. So you should use templates when logic is the same for different data type, okay, and also when you want a reusable and flexible code, okay, and as well also when performance is important, okay. So in summary, templates allow us to write generic and reusable code in C++, okay. And this part we have learned about function templates and class templates, and templates are powerful feature used heavily in the STL, okay. So if you enjoyed this part, like, subscribe, and I'll see you in the next part. Thank you.